Hi class. This is going to be a short video where I just step through a couple of examples to get us started that you can use to remind you of where we've been and what we need so that we're able to have a really successful class today.
We received the following properties of inequality in our discussion last time. Ways we can solve an inequality. Since if we add or subtract the same number to both sides of the inequality will still have the same solution set. And also we can multiply or divide both sides of an inequality by the same positive number and maintain the solution set.
So for instance, if we were looking at an equation like this, 3x plus 5 is less than or equal to 21. We could solve this equation for this inequality first by subtracting 5 for both sides. I'm doing that so that all my variable expressions are one side, and I would get 16 on the right. And then I could divide both sides by 3. So I have 3x over 3 less than or equal to 16 over 3. So x is less than or equal to 16 thirds. So I can rewrite that as 5 and 1/3. And so if I was going to draw the solution set for this problem, I could have my number line 0, 1, 2, 3, 4, 5, and then a little past 5 and not quite to 6 would be 5 and 1/3. And I want x to be less than or equal to, so I would start at that point. And then I would mark in that we could also have everything less than that, so everything to the left on the number line. But with an equality or an equation, we could also multiply or divide by negative numbers, as well as do a few other operations that we'll explore later this year. So for instance, let's take the basic equation, negative 2x is equal to 22. If negative 2x equals 22, then when it was an equation, we could just divide both sides of the equation by negative 2. And so I would get that x equals negative 11. And we realized this didn't work in the case of inequalities, because if I started out with the inequality negative 2x is less than 22, for instance, we could think about a sample solution, such as the number x equals 3 would solve this problem because negative 2 times 3 is negative 6. And that's certainly less than 22. But if I were to divide both sides of this inequality by negative 2 and just keep the sign the same, it's not true that x is less than negative 11 in this case. 3 is not less than negative 11. Let me change that color there so it's easier to see. And we know it can't be the same solution set because I came up with an example of a number x, in this case 3, that solved my original inequality, but it does not solve the inequality when I just took those sides and divided them by negative 2. So, two questions. Question 1, is there a workaround? And what I mean by that is there a strategy where I only use the properties that I do have? So can I just use my two properties of inequality, the ones up at the top of the screen that I'm underlining in red? And then the second question, which is also equally important, is, does this teach me a property I can use as a shortcut whenever I multiply or divide by negative numbers? And the good answer is that for both of these questions, yes. There is a workaround and a property I can use as a shortcut, and it's super simple and really fun. Okay, maybe not really fun, but there's nothing like the sense of solving a problem and feeling satisfied. So here's the workaround. Negative 2x is less than 22. We may not be allowed to divide by negative numbers, but we are allowed to add or subtract anything, whether that quantity is positive or negative. 2x is a number. I can add that expression 2x to both sides of the inequality without fail. Now, why would I want to do this? Well, when I add the 2x to both sides, on the left I get 0. 0 is a nice number. But the other nice thing is I get 22 plus 2x on the right. So now I've taken that negative coefficient, negative multiple on my x, and by adding 2x to both sides, I've eliminated the negative. And so now, if I want to do any multiplication or division later down the line, the coefficient on x is a positive number now. Isn't that great? I made it positive just by adding the quantity over. So let's take that one step further. Now I have this inequality. 0 is less than 22 plus 2x. To solve that inequality, I can use my other steps that I'm allowed. I can now subtract 22 from both sides of the inequality. And I'm choosing to do that because now all the straight up numbers are on one side and the algebraic expression in terms of x is on the right. And now the number that I need to divide by to get x by itself and know what values of x we're talking about is a positive number. So now I have a property of inequality that says dividing by positives is just fine. And I get negative 11 is less than x. Negative 11 is less than x. If we compare that to what happened in the original problem, when I didn't do anything to the direction of the inequality and I just tried dividing, you'll notice that we're looking at an exact reversal of the inequality sign. The x is switched which side of the inequality it's on. And that's going to happen every time, and it's how I'll generate a shortcut. We're going to do one more example together like this, now one that has 2 steps, and then you'll try some problems on your own. Okay. Negative 4x plus 7 is greater than or equal to negative 2x minus 19. The steps that we've used in the past for these problems still apply. I want to get all the x's to one side and all of the numbers to the other side. But the way I'm going to choose which way to move things is so that I end up with positive coefficients on x. So I notice that, well, I have x's on both sides. If I were to add 2x to both sides, now I have a negative over there. That wouldn't help me out so much because then I'd have to do another addition. Whereas if instead I add 4x to both sides of this equation, I won't have any x's left on the left, and 4x plus or minus 2x will be a positive number, positive coefficient. So on the right-hand side here, I'm going to get a 2x, 4x minus 2x. And then I'm going to look at the numbers next. You could also, a lot of times we actually do this in one step. You add all the numbers or subtract the numbers and the variable terms that you want to move all at once, and that's fine. But then the next move would be I need to get that negative 19 off of the right-hand side of the inequality. So I'm going to add 19 to both sides. So now on the left-hand side here, I'm going to get 26 is greater than or equal to 2x. Dividing by 2, I get 13 is greater than or equal to x. Let's go ahead and draw that solution set just to emphasize how we solve these problems. Let's draw the graph of the solution set. Here's 0, 13's way up here. We are told that we want x. X is not the one being eaten by the alligator, so We're allowed to be equal to 13 because of the or equal to on the x sign, but we want x to be smaller. So we're going to highlight everything over here. And once you've finished solving an inequality, I think it helps to triple check that you're right by picking some other number and plugging it into the original expression and verifying it would make it true. So let's do a good check of our solution. If I pick a number, I'm going to pick 1 because 1 is right here. It's still positive, so the math won't be hard. Notice -4 times 1 plus 7 is greater than or equal to -2 times 1 minus 9. Is that the case? Well, the right-hand side is -11, and the left-hand side is -4 plus 7, or 3. Yeah, that's true. We're good to go. Now, checking just one number isn't enough in general, but if you're fairly certain that the question you're trying to check is the direction of my inequality okay, this is a really great choice. So to sum up, I'm going to write down the steps, and it's as easy as pie. All you do is you add or subtract the variable term so that the coefficient on x becomes positive. And then you solve this new inequality. And there we have it.